Let's solve the reverse linked list problem on LeetCode. In this problem, we're given the head of a singly linked list. We need to reverse the list and return the reverse list. So in example 1, we have this list 1, 2, 3, 4, 5, and so we have to reverse it so it becomes 5, 4, 3, 2, 1. Similarly, 1, 2 becomes 2, 1. Let's take a look at this example. We have a singly linked list 1, 2, 3, 4. So let's take a look at this example to see how we're going to code the solution to this problem. So first and foremost, what we're going to do is we're going to create our own singly linked list, so a completely new singly linked list, something like that. Now we don't need to assign the first node in our singly linked list to be 0. This value is an arbitrary value. In the end, it's not really going to matter. So obviously we have the initial pointer to the list which they gave us, which is head. It's in the given. And obviously, when we create our own singly linked list, we need to assign it a pointer to point to that value. So we can just call that list. So L for list. What we're going to do is we're going to create two dummy pointers for each list. So something like that. We have dummy 1 and dummy 2. Now what I'm going to do first is I'm going to retrieve the number of nodes in the original list. And the way we're going to do that is in a while loop. We're going to say while d1.next is not equal to null, then count plus plus, where we initialize a integer count to be 0. And so every time d1.next is not equal to null, then we're going to increment our count by 1, and then we're going to update d1. So for instance, is d1.next equal to null? No, it's equal to 2, so count plus plus. And then what we're going to do is we're going to update our d1 to point at the next node, so something like this. It's hard to draw on the cursor. Obviously, once we update d1, this will no longer exist, and then we're gonna keep doing this until d1.next is null, and we'd stop at this node, and we'd return the final count, which is the number of nodes in our original singly linked list. So now with the count, we're going to iterate through the nodes in our original list and in a for loop. So what we're going to do is we're going to use this count to iterate through the nodes within our original linked list, and then we're going to do something similar to how we found the count. We're going to use a while statement, and we're going to say while d1.next is not equal to null again, and while d1 is not equal to d2, or rather while d1.next is not equal to d2. And we're going to do the following code, or the following sequence of events, I should say. So within our while loop, while d1.next is not equal to null, and while d1.next is not equal to d2, we're going to keep going and updating our d1 pointer. So while d1.next is not equal to null, is 2 equal to null? No, so we're going to update our d1 to point to 2, so on and so forth until we reach 4. Once our d1 is here, and obviously this no longer exists, we're gonna say d2.next is equal to d1, something like this. Then we're going to update d2 to be equal to d2.next, so then it would be something like this, and this no longer exists. And then we're going to decrement our count, so we're gonna process the remaining nodes, neglecting the last one because we took it into account. And we're gonna keep going on with this process. As you can, once we finish with the first iteration, we're going to reset d1 to be equal to head, so then this pointer will exist again, and then this will no longer exist. And we're going to repeat the cycle again, but this time we're not checking if d1.next is equal to null. We're going to check if d1.next is not equal to d2. So once we reach 3, we're going to check, is d1.next equal to d2? Yes, it is, since they're both pointing at the same node. So we're going to stop at 3. And then we're going to repeat the sequence of events where d2.next is equal to d1. And then we're going to update our d2. So let's actually begin coding now. So we need to create our new list. List node, we can call it list equals to new list node. And we need to assign an arbitrary value of anything. I'm going to put 0. And then we need to create our dummy pointers. So list node dummy1 is equal to head, and list node dummy2 is equal to list. Now we need to find the number of nodes in the original singly linked list. So int count is equal to 0, and while dummy 1 dot, or while dummy1 is not equal to null actually, then dummy1 or count plus plus, then we need to update dummy1. So dummy1 is going to be equal to dummy1 dot next, and then we need to reset dummy1 to be pointing at the same node as head. So now we need to iterate through the nodes in our singly linked list. So for int I equals to count, we want to start at the end. As long as I is greater than 0, strictly greater than 0, and we'll see why in a bit, I minus minus. Now we need to check our while condition. So while dummy1 dot next is not equal to null, and dummy1 dot next is not equal to d2 or dummy2, dummy1 update the pointer to dummy1 to point at the next node. So dummy1 is equal to dummy1 dot next, and then we're going to leave our while loop. So we're going to keep iterating through our nodes until this condition is broken. And then once this condition is broken, what are we going to do? We're going to link our dummy.next to dummy1. We're going to link dummy2, which is pointing at the new list we created. We're going to point dummy2.next to the node dummy1, wherever dummy1 is pointing. And then we need to update dummy2 to point at that node itself. Finally, we need to reset dummy1 to be pointing back to whatever head is pointing to, so we can iterate through the linked list once again. Finally, we need to do two things. Once we've reached a point where, if we take a look at this example, 1, 2, 3, 4, 5, once we reach 5, 4, 3, 2, 1, 1 should be pointing dot next to null. So dummy2 dot next is equal to null. And finally, we need to return list dot next, so we can skip the arbitrary value which we created when we created the list. So two things I'd like to preface is the fact that once we iterate through the list and reverse the order, if you notice 1, 2, 3, 4, 5, 5.next is null, so 1.next should also be null. If we ignore this line of code and you go through the example, you're going to see that 1.next is going to point back to 2, which is incorrect, so we need it to point to null so we can output the correct answer. And count here has to, or I has to be strictly greater than 0. And the reason why I has to be strictly greater than 0, not greater than or equal to, is because once we reach I equals to 0, we're going to point again at 1, and we're going to repeat this sequence of code to point dummy2.next at 2. But at I equals to 1, we already did these two steps at these two nodes. So this is going to be ignored, and we're going to keep going through our code because it won't terminate this while loop. And you'll understand more if you go through the example. So therefore, I has to be strictly greater than 0. And we need dummy2.next, or the last node, to point at null. So let's submit our code and see if it works. Perfect. So that was the reverse linked list problem on LeetCode. I hope you found that video helpful, and thanks for watching.